Worlds beyond our sun. Space is vast. Really, truly vast. It's a realm of endless possibilities and mysteries waiting to be uncovered. For centuries, we knew only of the planets in our own solar system. Our understanding was limited to the celestial bodies that orbit our sun. But what if I told you there are other worlds out there, worlds that exist far beyond the reach of our solar system? Planets orbiting distant stars, many light years away. These are exoplanets. They are diverse and numerous, each with its own unique characteristics. Imagine a star, much like our sun, but incredibly far away. A star that shines brightly in the vast expanse of space. Now picture a planet, circling that star, bathed in its light. That's an exoplanet. These planets come in all shapes and sizes. Some are giants, larger than Jupiter. These massive planets could have rings and multiple moons. Others are smaller, perhaps rocky like Earth. These could be potential candidates for hosting life. The discovery of exoplanets revolutionized our understanding of the universe. It opened our eyes to the vast number of worlds that exist beyond our own. It showed us that our solar system isn't unique. Planets are everywhere. They are scattered throughout the galaxy, each with its own story. And some of them, just maybe, could harbor life. The search for these habitable worlds continues as we strive to understand our place in the cosmos. Seeking distant suns. Finding exoplanets is hard. These distant worlds orbit stars far beyond our solar system, and locating them is a monumental challenge. They're incredibly faint compared to the stars they orbit. The light from these exoplanets is often drowned out by the brilliance of their parent stars. It's like trying to spot a firefly next to a spotlight from thousands of miles away. The contrast is so stark that it requires incredibly sensitive instruments to detect them. One way we find them is by looking for tiny wobbles in a star's movement. This method, known as the radial velocity method, relies on the gravitational interaction between the star and its planet. The gravity of an orbiting planet tugs on the star, causing it to wobble ever so slightly. These minute movements can reveal the presence of an unseen companion. We can detect this wobble from Earth. Advanced observatories and precise measurements allow astronomers to identify these subtle shifts. Another way is to look for dips in a star's brightness. This method, known as the transit method, involves monitoring the light curve of a star over time. When a planet passes in front of its star, from our perspective, it blocks a tiny bit of the star's light. This brief dimming can indicate the presence of an exoplanet. This is called a transit. By studying these transits, scientists can learn about the planet's size, orbit, and even its atmosphere. The search for another Earth. Why do we care about exoplanets? It's a question of curiosity, of understanding our place in the cosmos. Are we alone? Are there other planets like ours out there? Finding another Earth, a planet with liquid water, an atmosphere, maybe even life, would be one of the greatest discoveries in human history. It would change everything. The search for exoplanets is a search for ourselves, for other beings who might look up at the night sky and wonder, just as we do. Section 4. The universe's great choreographer. Now let's talk about gravity. What is this invisible force that holds us to the Earth, guides planets around stars, and shapes the universe itself? Gravity is a force of attraction between any two objects with mass. You have mass, the Earth has mass, that pen in your hand has mass. And all of these things attract each other with gravity. The more massive an object, the stronger its gravity, and the closer objects are, the stronger the pull between them. Section 5. Gravity's cosmic dance. Think of a bowling ball on a trampoline. Imagine how the fabric stretches and bends under the weight of the ball. It creates a dip in the fabric, right? This dip represents the warping of space-time caused by a massive object. Now roll a marble across the trampoline. Watch how it moves. It doesn't travel in a straight line. Instead, it follows a curved path. It curves towards the bowling ball, pulled by the dip it creates. This is similar to how gravity works in space. That's kind of like gravity. Massive objects like planets and stars warp the fabric of space-time. Massive objects warp the fabric of space-time, creating what we perceive as gravity. This warping affects the motion of other objects. Planets orbit stars because they're trapped in the gravitational well created by the star's mass. This keeps them in a consistent orbit. Gravity is what holds galaxies together, binding countless stars into a cohesive structure. It's also what makes black holes so powerful, with their immense gravitational pull that nothing can escape. And here on Earth, Gravity is what keeps our feet firmly planted on the ground, allowing us to walk, run, and live our daily lives. Section 6: Exoplanets and the Pull of the Cosmos. So, how do exoplanets and gravity connect? Well, gravity is how we find exoplanets in the first place. Remember those wobbles and dips in starlight? Those are caused by the gravitational pull of unseen planets. Gravity is also what makes exoplanets so diverse. Different masses, different distances from their stars, all of these factors influenced by gravity lead to an incredible variety of worlds. As we continue to explore the cosmos and discover new exoplanets, we'll continue to learn more about gravity, this fundamental force that shapes our universe.